In section 2-3, the limit theorems, we're going to begin by solving limits using direct substitution. And then we're going to use that knowledge to figure out what happens to the limits of composite functions. So let's begin by looking at the function f of x is equal to 3x squared minus 48 all over x minus 4. So the first thing I want to do is figure out what f of 4 is. Now, I know that you know it's not going to happen, right? X minus 4 is my denominator. My denominator can never be 0, okay? It's never going to happen. But just for fun, let's plug it in, okay? So that would give me 3 times 4 squared minus 48 all over 4 minus 4. So I know my denominator is going to be 0. And in fact, if I simplify my numerator, that will also be 0. This form of 0 over 0 is called an indeterminate form. We know nothing about it, okay? But just because my function can't be evaluated at 4 doesn't mean the limit doesn't exist as x approaches 4, okay? Even though I'm going to have some sort of discontinuity in my function here. There could be a hole, there could be a step discontinuity, it could be removable. I don't really know and I don't really care, but I can still see if I can figure out what my limit's going to be. So let's do that now. So in order to solve this limit using direct substitution, we're going to need to simplify this expression as much as possible. So just to work on our notation a little bit, we're going to write out every step. So the first thing we're doing is taking the limit as x approaches 4 of f of x, okay? So if I substitute in what f of x is, that would mean we are looking for the limit as x approaches 4 of 3x squared minus 48 all over x minus 4. Now, I still can't really do anything with that, right? It's an indeterminate form. We already talked about that. We're going to end up with 0 over 0 like we did right here. So let's simplify this. Let's think back to Algebra 1 a little and simplify. Okay, so let's factor out 3 from my numerator. So that would give me the limit as x approaches 4, whoops, I forgot the arrow, of 3 times x squared minus 16 all over x minus 4. Now again, from Algebra 1, you should immediately recognize that this is a difference of squares. So let's factor that as well. So, just move the page over. When I do that, I'm going to get the limit, because I'm still taking the limit, right? I haven't done anything besides simplify my function yet. I'm still in my limit of 3 times x plus 4 times x minus 4 all over x minus 4. So right away, I hope you notice that these cancel. Those binomials are the same and they cancel. Now, if I think ahead for a second and I plug in 4 into my value of x, I no longer have this indeterminate form. So at this point, I can now take the limit simply by plugging in 4 into my function, okay? So now that I'm taking the limit, I no longer need to write limit. I'm doing it, okay? So this is going to get me to 3 times 4 plus 4, which is equal to 24. So as a final answer, I would write the limit as x approaches 4 of f of x is equal to 24. There you go, full credit. Awesome. Okay, so now that we've taken the limit using direct substitution, we're now going to look at what happens when we take the product of limits. So let's move down the page a little, bring it in. There we go. Okay, so I know that g of x is equal to 2x plus 1, and I know 2x plus 1, and I know that h of x is equal to 5 minus x, and I'm told that f of x is the product of g of x and h of x. So just to make sure we're on the same page, f of x is equal to 2x plus 1 times x minus 5. Fabulous. So we're going to use our calculator to graph g of x, h of x, and f of x and use a trace function to find the limit as x approaches 3 of g of x, the limit as x approaches 3 of h of x, and the limit as x approaches 3 of f of x. So go ahead and use your calculator to figure out those limits. If you did not want to use your calculator, you could have also used direct substitution as we did in the example above to calculate the limits, especially since we know that both of these functions are lines, and lines are continuous, okay? Now, if you were going to use direct substitution, it would look like this. The limit of x approaches 3 of g of x is equal to 2 times 3 plus 1. You're literally directly substituting it in to get the value of 7, okay? You could do the same for h of x and the same for f of x. The process would be the same, okay? So if I do that for h of x, I'd get the limit is 5 minus 3, which is equal to 2. And if I did it for c, I would get 2 times 3 plus 1 times 5 minus 5, where's my pen? 5 minus 3, okay? So if you did that, 2 times 3 is 6, plus 1 is 7, 7 times 2 is 14. So now my question to you is, what do you notice about the relationship between your answers in part A, so the limit of g of x, the limit as x approaches 3 of g of x equals 7, and part B, which is the limit as x approaches 3 of h of x equals 2, to the relationship in part C. So go ahead and fill in that relationship, and I will check it tomorrow in class. Okay, let's move on now to look at the sum of limits. So our functions, g of x and h of x, are going to be the same as the functions we looked at for our product of limits. So, and f of x is going to be g of x plus h of x. So f of x would then have to equal 2x plus 1 plus 5 minus x. If you want to simplify that, go ahead. You absolutely do not have to. So at this point, you should notice that your limit as x approaches 3, whoa, that's crooked. Your limit as x approaches 3 of g of x should be the same as it is above because, again, it's the same function. So that limit equals 7, okay? Your limit for part B would be the same as it was for the product of limits, which would be 2. So the only new thing we need to find now is the limit as x approaches 3 of f of x, which would be this new function. So you're welcome to do that on your calculator. You're welcome to do it using direct substitution. Whichever way makes the most sense for you, makes the most sense for me, okay? So if I just plug it in, because I will get, let's zoom in so I have somewhere to write. So if I just plug it in, I am going to get, this should have an equal sign, 2 times 3 plus 1 plus 5 minus 3. If you want to put your each function in its own set of parentheses, you can. It's not necessary because we're dealing with addition here. So when you do that work and you add it all together, you're going to get 6 plus 1, so 7, plus 5 is 12, minus 3 should be 9. So again, I want you to look at the relationships in part A, part B, and C. So what is the relationship there? If I'm summing my functions, if I'm taking the sum of my two functions, what am I going to do to my limits? How can I get from 7 to 2 to get to 9? Okay, what operation am I going to use? Go ahead and fill in the answer to part D, and I will check that tomorrow in class. Okay, so let's continue now for the last part of today, or of this set of notes, I should say, and look at the quotient of your packet. Okay, so when we look at the quotient of limits, again, we're working with our limits, the same function for g of x, the same function for h of x. So let's just skip ahead right now and fill in those limits. We know that this one's going to equal 7, and that one is going to equal 2. Fabulous. Okay, so f of x is the quotient, right? We're dividing, remember, quotient division. So we're just going to write that in for us. So we're going to get 2x plus 1 divided by 5 minus x. If you are using your calculator, which you totally can, to calculate this limit, make sure that you put in each function in parentheses before you divide, okay? Otherwise, your function will not actually be the quotient. Your order of operations will be incorrect. Your numerator needs to be in parentheses, and your denominator needs to be in parentheses before you hit graph, okay? So if you are using the trace function, great. Again, I'm going to go ahead and just use direct substitution. So when I do that, I'm going to get, my numerator is going to be 2 times 3 plus 1, and my denominator is going to be 5 minus 3, which simplifies to be 7 over 2. So again, my last question to you of the day is find what happens, or what is the relationship between part A, part B, and part C. Answer part D, and we'll go over it tomorrow in class. Okay, so moving on to part E. So I want to now look at the function, or I now want to find the limit as x approaches 5 of f of x. So if I look back at my original function for f of x, I know that my denominator, I know that my denominator will be 0 if I use direct substitution, okay? I also know that there's nothing I can cancel, okay? Those two binomials have nothing in common. So the easiest way to do this is to look in your graph. So go ahead and graph this function in your calculator, and then we're gonna use the table to figure out what happens. As you're graphing this function, keep in mind that we know something is gonna happen when x equals 5. So you want your x window to be at least 5, okay? So 6, 7, 8, it should be bigger than 5 so we can figure out what's happening to our graph as x approaches 5. So go ahead and pause the video while you figure out what this graph is, okay? Do not press pause, put it in your calculator so you can follow along. Okay, so since I want to show you guys what we're looking at, I'm going to just sketch a graph of this function, okay? You should already have had this drawn or you should have already graphed this in your calculator. So this is my x-axis, this is my f of x axis, okay? I'm going to make this 0.5, and you should be able to tell immediately that there is an asymptote at x equals 5. So my function's going to come up from the x-axis like that, and it's going to come down like that. Okay, now, as I've told you multiple times in class now, in order for a limit to exist, when we approach a c value from the left, our limit needs to be the same as when we approach that same value, which in this case is 5, from the right. Since that does not happen in this function, they're clearly going to different values, right? From the left, we're going off to positive infinity, and from the right, we're going to negative infinity. We would say that this limit does not exist, okay? You can also look at your table of functions or your table of values in your calculator. So hit second table, and you'll see that that value when x equals 5 it does not show up. It'll just say error undefined, okay? It does not exist there. Okay, so if we move on to example 1, we're going to solve this limit that we've already actually looked at today, but we're going to solve it step by step, and we're going to justify each step. Because there are multiple ways to approach this problem, I want you to do it on your own. Do your best to justify each step. Those justifications can be, you can just say algebra, division, okay, direct substitution. They don't need to be fancy calculus words. Those division, algebra, those are all very legitimate steps you could take. So do the best you can on number 1, and we'll also discuss that tomorrow in class.